You are designing a temperature control system for a greenhouse. You can use if-else logic to switch between heating and cooling modes based on the current temperature. Isn't it wonderful? Or when modeling a battery charging system, you can use if-else logic to control the charging process. If the battery voltage is below the set value, the charger initiates the charging. Otherwise, it stops the charging process. Or when simulating a home automation system, if-else logic can be used to control various devices based on the user input or sensor reading. For instance, if a motion sensor detects a movement, the system turns on the lights. So these are few examples where you can use if-else logic in Simulink. But the most important thing is how to implement if-else logic in Simulink. So that is what we are going to do in this video. So without wasting time, let's get started. Let's imagine we are building a smart temperature control system where we are going to implement and learn how to use if-else logic in Simulink. For that purpose, here I have imported data like wind speed, temperature, humidity and solar irradiance. And all this data I am importing from a weather station. And we are going to use this data to make decisions using if-else logic. But before moving ahead, it's important you know how to import data to Simulink. If you know how to import data, that's fine, move ahead. But if you don't know how to import data to Simulink, then I refer you to watch one video on how to import data to Simulink, which is really very useful tutorial. The link of that video is in description and above here in I button. So refer this video to learn how to import data to Simulink. And now let's build a logic circuit. So first let me show you what are the data that I am importing. This is the scope and I am connecting this data with scope. So let's just run this thing to observe what are the data that we are extracting from weather station. So these are the data which we have imported from weather station. Now using this data we are going to create a logic. Now what is the condition that we are going to implement? The condition is if temperature is greater than 28 degrees centigrade, we supposed to turn on the cooling system. Let's say we supposed to turn on a fan, right? So this is the graph of temperature. So when this temperature is greater than 28 degree, we supposed to turn on the fan, and when it is again below 28 degree, we supposed to turn off the fan. So this is what we want to implement in this circuit. So let's close it. Let's open library. In library we'll go to signal routing. In signal routing we are going to use the switch. Let's add the switch. Now just open the switch. Now in this switch, this is the criteria for passing the first input. So this U2 is our input, and here we can set a varieties of criteria if U2 is greater than or equal to threshold, if U2 is greater than threshold, or if U2 is almost equal to 0. So let's say our requirement is if temperature is greater than 28 degrees, so we'll use this U2 greater than threshold and we'll set our threshold to 28 degree, right? Okay. So now we have set the threshold limit to 28 degree. So now U2 is our temperature. So let's connect this to our temperature. So this temperature's reading is given to this switch. And now we can set two conditions. So in order to set the conditions, if input is greater than 28 degree, the upper input is reflected in output. Or if the input is less than 28 degree, the lower input is reflected in output. So in order to turn on something, let's say we'll give a constant. So we'll use a constant block and we'll give the magnitude as 1. We'll take another constant block, give it over here and we'll make it 0. So the logic is set in this manner. If this temperature which is given to this switch, if this temperature is greater than the threshold that we have set, which is 28, so if temperature is greater than 28, this 1 will be reflected in output, or if it is not greater than 28, this 0 will be reflected in output. So let's use a scope to observe the output. and let's connect this temperature with the scope so that we can compare the variation in temperature with the output. Now let's run, and here you can see when the temperature is increasing this 28-degree mark, the output is shifted from 0 to 1, and again when it is reducing its magnitude from 28 degree, the output is again 0. So that's how this logic functions. Now I'll give you a little bit more complex. We have the more complex new condition, and the new condition is, what if we need to turn on the fan when temperature is higher than 28 degree and solar irradiance is greater than 30 watt per meter square. So this is our new condition. So here we have two conditions: temperature is higher than 28 degree and solar irradiance is greater than 30 watt per meter square. So now let's open this scope, and here the solar irradiance is this green one, right? So first we'll connect the solar irradiance in this scope. Now I'll take one more switch. Now I'll open this switch, and in this switch I'll set the threshold of 30 watt per meter square. So this is my first logic. If the solar irradiance is greater than 30 and wind speed is greater than 28, then and only then the output will be 1, right? So I'll give the input from solar irradiance. So this is my input. Now first I'll take a constant block with 0 magnitude and connect over here, and then I'll connect a constant block with 1 magnitude and connect over here. Now what I'll do, I'll connect the output of this block to this upper section. So let's remove this line and connect it over here. Now what will happen in this logic, let me explain quickly. So let's say when temperature is greater than 28 degree but solar irradiance is less than 30 degree. So what will happen, this 0 is reflected in output and the same 0 is reflected over here. So the input to this logic is 0, and when the temperature is greater than 28 degree, the upper logic is connected in output and the upper logic is still 0. So our main output will still remain 0. So cooling system will not be turned on. Now let's say it is less than 28 but solar irradiance is greater than 30. So when solar irradiance is greater than 30, one output will be reflected over here, but temperature is less than 28. So what it does, it will take lower output and reflect this 0 input in output. So in both the case our condition is get fulfilled. Only and only when the solar irradiance is greater than 30 and wind speed is greater than 28, in only that condition the output will be 1. Let's run and observe. See, here you can see solar irradiance is greater than 30 in between these 2 points and temperature is greater than 28 degree in between these 2 points. So what is the common time when both the logics are true? The common time is this much only. And you can see the output is 1 for only that much of period of time. So that's how you can implement if-else logic in Simulink.